Dr. Erica, and today we're going to talk about circuits and what types of circuits there are. There's two types of simple circuits. There are series circuits and there are parallel circuits. And we're going to talk about each type and where you would see them in your house. So a parallel circuit is when everything is attached to your battery. So for example, if I wanted to connect a bunch of LEDs in parallel, I could attach them all straight to my battery, and the ends of each LED, if we considered them to be sort of arms almost, they're holding hands with the battery on both sides. Now I can attach a lot of LEDs to this battery in parallel. And then you see they all light up. Now if I take one and I make it so it doesn't light up, maybe I switch it around, you'll notice that the other LEDs stay lit. So these guys, it doesn't matter what their neighbors are doing, it only matters what they are doing because they're all touching the battery. Now, places you would see this in your house are places like your electrical sockets. So if one electrical socket isn't working, it doesn't matter for the one next door, right? So you can plug in your hairdryer into one socket and a toaster oven into another socket, and if the hairdryer goes out, the toaster oven will still make your toast in the morning. There's another type that's called a series circuit, and that's when instead of holding hands with the battery, they hold hands with each other. So here I have a battery that's going to an LED, and just to make sure it lights up, I can make my little switch and close that gap. So here I have one LED that is sort of in series or parallel with the battery because there's only one. Now I can add another one, and I want to make sure that when I'm adding it, I add it in the right direction because LEDs, they're sort of the one-way streets. So I'm going to test and make sure I get my direction right. And so now I'm going to make these two LEDs hold hands with just a little piece of copper tape. Now the copper tape is basically acting like a wire between these two LEDs. And so I'm going to tape them down to each other like this. You just need to get good contact between each of them. And then again, I can try to close my switch. Now this time, nothing lights up. And that's because the battery doesn't have enough push in it to push through both the LEDs in a row. So in parallel, it was just sort of pushing through each of them singly, not in a row down the line. And what happens, you'll notice, is the first one doesn't stay lit. So remember when we were looking at parallel, if I had one bulb that was blown out and didn't work, all the other ones were totally fine. Here, if I have one that's not working, nothing's going to light up. So this is similar to an open circuit. There's no switch to close and the current can't get all the way around. Now places you'll see series circuits in your house are like your light switch. So I turn my light switch on, it's only operating one light, it's in series. Your refrigerator also uses a series circuit, and that's because it's trying to regulate a temperature. So let's say it says, oh, it's a little too warm in the refrigerator, let's turn on the cooler, and the cooler, it cools it all, and then it clicks off. There's no secondary circuit that sort of keeps going even if that one turns off. You don't want it to keep going because then your refrigerator would turn into a freezer. You'd also see this in your water heater. You have a circuit where there's all of these elements that are hooked up in series in sort of a big S, and those warm up the water. And when I turn it off, I don't want to turn off just one element, I want to turn them all off because otherwise my water will get too hot. So those are also in series. So you want to use series when you want something, if something goes wrong, you want everything to stop. That's when you use series, because if something goes wrong, you have this switch that's open in your circuit. Parallel is sort of, you have this backup plan all the time. So for example, Christmas lights. If you have one light in your Christmas light strand, you don't want the whole strand to be gone. You just want to be able to say, oh, that's the light, it's the one that's not lighting up, we'll just replace that single one. If it was in series instead of in parallel, you'd have to go through each and every light bulb until you found the one that when you replaced it, it lit the strip back up. So that's the difference between series and parallel. Again, in parallel, all of sort of the circuit pieces, for example, our LEDs, the hands are touching the batteries. And in series, the hands are holding onto each other to make sort of a big, nice long loop. So thanks for checking with us. We hope that you will enjoy our Squishy Circuits Lab as we learn all about circuits. You can find all of our fun projects on Facebook and Instagram. And of course, you can also support Kids Science through our Patreon page where you get all of our fun labs as they come out.